3, review test number 3. Going over some questions that we missed. Most missed question on our list is number 4. Number 4. Number 4 reads, and hopefully you guys have this in front of you. It shows you a triangle, looks something like this. Okay, I'll try to do my best with it. I know that's not perfect. There's 10. There's 3x plus 4y. There's 4x minus 4y. We have 4. We have x and x. Okay, here's the thing that you have to remember, is that these lines that are tangent to this circle that come back to a common point are congruent to each other. So, for instance, 4x minus 4y is equal to 4. X is equal to x. 3x plus 4y is equal to 10, right? Did we know that going in? Okay. All right, so here's the challenge here, is that none of them is just like one variable equal to a number in an equation. So we're going to look at a situation where I have two equations with the same variables equal to a number. All right, now I can simplify, right? In this case, just because of how it works, right, there's different strategies, but I'm going to add these two equations together. Why? Because the y's will cancel. All right, so 3 plus 4 is 7x. That's 14. X equals 2, right? Right? Okay, so now I know what x equals. Now all I have to do is solve for y, correct? So I could plug that back into an equation. Doesn't matter which one. 4 times 2 minus 4y equals 4. Here's 8 minus 4y equals 4. Subtract 8, negative 4y equals negative 4, so y equals 1. So x is 2, y is 1. Is there more than one way to solve this? Yeah. All right. You could solve using a matrix. You could rewrite it as two linear equations and solve. Right? There's a lot of different things you could do there to solve for either x or y. Does that make sense? Yes? Okay. So the reason I say that is on the test, you might not be in a situation where your y's just cancel out whenever you add the equations up. Okay? You might have to try something else. Okay, but does this make sense to us? Okay. All right, then I can go on to question number 9. Question number 9. All right. Okay. So we've got square root of 5y minus 9 plus the square root of 5y equals 9. Well, you had a question like this on your last test, except it was easier, right? In this one, we've got square root of 5y minus 9. I'm going to subtract. Okay, so I get equals 9 minus square root of 5y. Okay, now to get rid of the square root on the left-hand side, I have to square both sides. All right, so that's going to give me 5y minus 9, but over here, the common mistake is we just want to square the terms that are inside the parentheses rather than squaring the whole set. Right, what I actually have to do here is FOIL. Right, and I see some people saying that, so I'm hoping that that wasn't part of our mistake, is that we didn't FOIL. So I'm going to get rid of this little square sign there, and I'm actually going to write it out, 9 minus radical 5y. Right, so I get 9 times 9 is 81. Minus 9. In fact, what I know is going to happen is that my 9s are going to double. Right, because I'm going to get negative 9 radical 5y, and I'm going to get negative 9 radical 5y again, correct? So if nobody minds, can I go ahead and write that up as negative 18 radical 5y? Do we understand how we got it? If you don't understand how we got it, then I need to show negative 9 radical 5y, negative 9 radical 5y. All right, now I have negative radical 5y times negative radical 5y, which is going to be positive 5y. Okay, so I've got that. All right, now one thing that I can notice about this as I begin to simplify and try to solve for y is that my 5y's cancel out, right? Okay, so I have negative 9 equals 81 minus 18 radical 5y. Okay, we're trying to isolate 5y, or sorry, isolate y. The first thing that we do is we're going to subtract 81 from 9, all right, which would be what, negative 90? Negative 90 equals negative 18 radical 5y. Okay, we're just following the reverse order of the order of operations because we're moving things across the equal sign, which has us do things opposite order. So now I'm going to divide by negative 18. Okay. What is it? 5 times, and it's even because they're both negative. Or sorry, not even, but positive. All right. So I get 5 equals square root of 5y. So now I'm going to do what I did up there earlier to get rid of the radical on the left, except now I'm trying to get rid of the radical on the right. So I'm going to square both sides. So I get 25 equals 5y. Continue to carry this down. Okay, divide by 5. 25 divided by 5, y equals 5. All right, is that a lot of work? Yeah, it's a lot of work, but is any of it? It's not impossible to do. Okay, it's just remembering your process. Okay, foiling being probably the biggest part of that. Okay, be careful. All right, and if I talk really fast, it's because I'm going to try to get as many done as I can in the next 20 minutes. All right, 13. All right, 13. X to the negative first plus y to the negative third over x squared y to the negative fourth. All right, let me look at something here. Yep, that's what I thought. All right, so if we haven't seen this already, what we're actually going to do is we're going to split this into two different equations. All right, we're going to write x to the negative first over x squared y to the negative fourth plus y to the negative third over x squared y to the negative fourth. Okay? Problems, questions? Okay, what that allows me to do is, I couldn't before, but I can now. I can move this x down, and I can move this y up, right? So that I'm getting positive exponents for those variables, okay? Which is going to write itself, because I'm moving that down, I'm leaving just 1 up there, okay? Right, this is giving me x cubed. Oh, and I also, let's move that y up. So let's not just put a 1 up there. Let's put our y up there. So we got y to the fourth over x cubed. Plus, over here, we're adding 4 to negative 3, so we're just getting y to the first over x squared. Okay, now I have two fractions, and one is got x cubed in the denominator, the other one's got x squared in the denominator. What is my common denominator? X cubed, and how do I get that? Multiply by x only on the right-hand side, right? Okay. All right, so that's leaving me with y to the fourth over x cubed plus xy over x cubed, which we can write as a single, where we're going to get, hold on, let me make sure that I've got it, y to the fourth plus xy over x cubed. That's my answer. Okay, biggest thing you need to know is split it, then get positive exponents, then after I've got that, get common denominator, simplify. Okay, questions, concerns, theories? No? Okay. All right, that was 13. We're going back to number 2. 2, find the sum of the measures of the interior angles and the sum of the measures of the exterior angles of a regular nonagon. Okay, so sum of the interior angles is written off as n minus 2 times 180. Okay, if it's a nonagon, right, we're doing 9 minus 2 times 180, or 7 times 180, which I'm being told by comments in the back that that's 1260 degrees. Is that correct? No? Is it not? What's 7 times 180? It is that. Okay. All right, so this is the sum of the interior degrees of a regular polygon. Okay? Now it wants to know, and the sum of the measures of the exterior angles of a regular nonagon. If I'm not wrong here, because it said sum and it didn't want to know the individual, I don't even have to do any math for this. Because for any polygon, the sum of the exterior angles is always one number, 360 degrees. Imagine walking around any figure. To get back to where you started from, you're going to end up going 360 degrees. Okay? All right. So you only really need to do anything to solve for the first part, which is the sum of the interior angles. Now, if it had said what is one exterior angle of a regular nonagon, you would take 360 and divide it by 9. Okay? Does that make sense? Okay. All right. Let's see from here. Number 3. 3. A total of 128 blue cars and red cars were in the parking lot. All right, so red plus blue equals 128. All right, do we understand the first equation? Okay, we're just grand totaling things. If the number of blue cars exceeded 3 times the number of red cars by 4, okay, so blue exceeds, which means I have to subtract a number from it, and that number I'm going to subtract is 4. Let's see, exceeds 3 times the number of reds, so that's 3R. How many of each car were in the parking lot? Okay, well, what I could do, and what I will do, is I'm going to add 4 to this side. The only reason I'm doing that is because that allows me to get an equation where I have a solution for one variable. Does that make sense? All right, now, you could set this up in different ways so that you could solve it using a matrix. Right, so I could change b minus 4 equals 3r to b minus 3r equals 4. And then that way I've got r and b on the same side and a constant on the right-hand side of the equal sign. I could set up a matrix, right? But I'm going to do it this way just so you're seeing something, where I've got r, and now I'm going to substitute in for b. 3r plus 4 equals 128. Okay, that's giving me 4r plus 4 equals 128. That gives me 4r equals 132. Okay. Did I do something wrong? Oh, you add. Okay, yeah. Yep, sorry. Subtract, so it should be 124. Sorry, brain fart. All right, what's 124 divided by 4? 41. 31. All right, so I have 31 red cars. I can go back up to my original equation. 31 plus what is 128? So 128 minus 31. 97 blues. Okay, was that the answer? Hopefully. 3197. Yep. Questions there? Did we understand the process? Okay, question? If that's how you set it up. Her question was, if we set it up as a matrix, is R going to be first, then B? Yeah, let's see. So if I have R plus B equals 128, then over here I need to have negative 3R plus B equals 4. So that would give me my R first and then my B. So it's a 2 by 3 matrix. It's going to go 1, 1, 128, negative 3, 1, 4. And then I'll RREF it, and it should give me 31 then 97. All right, so you can test that. If I'm wrong, tell me. Okay, but I shouldn't be wrong. There's no reason. All right, what was that? That was number 3. Let's see, we're on to number 5. Number 5. Something like that. 70, 80, X, Z, Y. Okay, well, Y and Z are really easy to find, okay, because Y is double the inscribed angle that intends it. Okay, so Y is 160. Do we get that? Z, or sorry, subtends it. So Z also, right? Z is double the inscribed angle that subtends it. So Z is what? 140. For X, I can do one of two things. I can add up 140 and 160, subtract that sum from 360, or I could take, I've got 80 and 70 is 150. The remaining degree here is 30, right? And double that so that for X, I'm getting 60 degrees. Right, which should make sense to us because 160 and 140 is 300. The remaining number of degrees is 60, so for a couple different reasons I can see that working. Okay? That makes sense. Great. All right, I'm kind of interested to know what we've gotten down to because 5, what was 5? 5 was still a 5. Okay, so we're into the 5s. What was number 12? Number 12, we're still in the 5s. All right. I would like to get down to, at least the 4s. All right, number 12. Okay. It's not a great picture start here, but 15, B, A, 5, 12, C. All right, the easiest thing to solve for here is A, right, because it's the hypotenuse of this small triangle. So 5 squared plus 12 squared equals A squared. Okay, we got 25 plus 144 equals A squared. That's going to be 169 equals A squared. Square root of 169 is 13 equals A. Okay, does that make sense to us? Okay, the other thing that we want you to understand, or hopefully you understand, is that these two triangles are similar, which means their side lengths are proportional. So if I want to find, let's say, C, I can set up a proportion so that I have 15 over 5. That's 15 to 5, okay, is C plus 12, okay? This whole length over 12. Now, cross multiply and divide. I got 15 times 12. I don't know what that is off the top of my head. You're going to have to help me out. What's that? 15 times 12 is 28. 180. Okay. 180 equals 5C plus 60. Okay, subtract 60 from 180. You're going to get 120 equals 5C. Divide by 5. Is it 24? Okay, I'll trust you now. Okay, so we got C is 24. Okay, at this point we could do a couple different things because we know that this is 13. Let's go ahead and do this. Let's say 15 over 5 equals, let's see, if we're doing 15 over 5 and we want to solve for B, we're going to do B plus 13 over 13. Okay? So what's 15 times 13? 195. Is that right? Yes? Okay, cool. 195 equals 5B plus 65. Okay? Subtract 65. All right, which is what, 130 equals 5B. Divide by 5. B equals, is it 26? Okay. Do we understand that? There's a lot there, but it's basically its proportions in Pythagorean theorem. So be careful that you don't just look at it as b alone, but this whole side is b plus, right? This whole deal along here is c plus. Okay. Let's see, we're up to 15. 15. All right, I cubed plus 3 minus negative 3i all over 2 minus I. All right, we're going to simplify the top as much as we can. That's made up of 2 i's and a third I. So 2 i's is negative 1, right? So that would be negative 1i, correct? Negative 1i plus 3 plus 3i, right? That simplifies to 3 plus 2i over 2 minus I, right? Okay. Now this is where a lot of people stop and they'll end up getting this wrong because we can simplify this, but we have to multiply by the conjugate. So 2 plus I and 2 plus I. I guarantee you right now that I will count a lot of these end up wrong because you will stop too early. Now we FOIL. Okay, 3 times 2 is 6. 3 times I is 3i. 2i times 2 is 4i. Okay, and 2i times I is 2i squared, which is negative 2. Do we get that? I know I didn't write that, but do we understand it? Great. All right, down here we got 2 times 2 is 4. Because it's a sum difference, I only have to multiply the first and the last. So I have negative I times I, which is negative I squared. I squared is negative 1, so it's negative 1 times negative 1, which is positive 1. Okay, hopefully if you watch this, you're listening. Okay, so we have 5 on the bottom. Up here, we can combine like terms so that I have 4 plus 7i divided by 5. Let's see, this is number 15. So yeah, I will take it written like this. The way that it's written in the answer key is 4/5 plus 7i over 5. Both are correct. I'll take both, or either. Okay? This makes sense? Hopefully. Okay? I got 3 minutes. I'm going to try to do at least one more question. 14. How many have I done? 1, 2, 3, 4, 5, 6, 7, 8. This will be the 9th question, so 14. I don't know if I'm going to get through all this. Okay, square root of a to the 4th, b squared. Okay, the rest of this is outside. A cubed, b to the negative 2nd, squared over cube root of a cubed, b to the negative 6th, square root of b to the negative 1st. Okay. Let's start with the top. That's going to be a squared b. And then I'm going to get a to the 6th, b to the negative 4th. Okay, simplify that. I'm going to get a to the 8th, b to the negative 3rd. That's my numerator. Does that make sense? Okay, great. All right, I'm going to try to simplify my denominator over here. That's going to be a b to the, negative 2nd. Let's see. This is b to the 1/2 to the negative 1st. So what that's going to be is b to the negative 1/2. Does that make sense? Okay, so there's a lot going on there. So down here I have a, and then I've got to add these. So that's going to be what? B to the negative 5/2. B to the negative 5/2. Okay? So what I want to do is I'm going to actually bring this a up, and I want to bring this b down. So I should get a to the 7th, because I'm subtracting 1, over, and so what I'm doing is I'm taking negative 2.5, and I'm adding 3 to it, so I should be left with a positive 1/2. hopefully, if I look at this, that's the answer. 14, that is the answer. Okay, so you got a lot to look at there. Okay, take it slow, take it one step at a time. Is that enough to get you guys kind of settled on tomorrow, or no? Which ones, if I had to, do I need to do in my own time? I'm seeing somebody say 10, 17. You want me to just do the rest of them? Okay, yeah, no. What ones do you want? You're like 8. Okay, 11. Is that it? What else? Is that it? Well, if you don't know for sure, I'm not doing it. You're just going to have to study. Okay. Well, I've done 9 of them. So if you do the 9 that I gave you, there's 10, 11, 12, 13, 14, 15. You'll have 15 questions that have been reviewed for you. So I'm going to hit pause on this video, and I'll come back to it, what will seem like in just a second. All right, back from lunch. Let's look at the next one, which looks like number 17. Okay, 17. All right, 17 wants an outline of a proof. So what you should be able to show on this is I got a right angle here, there. Those sides are congruent. I get something like this. So what I'm looking for is triangle TAB. It's congruent to triangle TCB. Right, we've got T, B, A, and C here by side angle side congruency postulate. So TA is congruent to TC by CPC TC. You'll notice it's not a 2-column proof, but I will accept that. Okay. All right, so that was 17. Need to do number 10. Radical 3, negative radical 3, it's negative radical, well, radical negative 9, radical 9, radical 3, minus 3i times negative radical 3, or radical negative 3, radical negative 3. First thing I'm going to do is I'm going to take out the negative radicals. I'm going to replace them with i's. So we got radical 3 times radical 3i plus, let's go ahead and kind of put some things together here. We've got radical 9i, radical 9, radical 3, minus 3i, radical 3i, radical 3i. Okay. Well, radical 3 times radical 3 is 3, so that's going to give me 3i. Over here, radical 9i is the same as 3i times radical 9, which is 3, times radical 3. So if I'm looking at that, I've got 3i plus 9i radical 3. We come over here. Let's see, we've got radical 3i times radical 3i, which is going to be 3i squared, which is going to be negative 3. So we've got negative 3i times negative 3. So that's going to end up being positive 9i. So now I'm looking at what I can put together, and it looks like I can get 12i plus 9i radical 3. Let me see what their answer comes out to on number 10. Okay, and what they do with this, I would accept this answer, but what they end up doing is they factor out the I, so we end up with 12 plus 9 radical 3 with the factored out I, and that'll work for that. All right, it's 10. Looks like we need number 7. Use the quadratic formula to solve. Looks like we've got 3x squared equals 2x minus 4. Let's get everything into the quadratic equation. So 3x squared minus 2x plus 4 equals 0, just moving everything over to the left by the opposite operation. We've got an a, b, and a c here. Let's see, a, b, c. We should know that our equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to start off with 2, not negative 2, but 2, because it's the opposite. And we've got negative 2 squared minus 4 times 3 times 4 all over 2 times 3. Bring this down, give us some room. 2 plus or minus over 6. Square root of, well, we know that's 4. And we're going to get negative 12 times 4, which would be negative 48. Okay, so we can simplify this on down. Okay, so we've got 2 plus or minus square root. Looks like negative 44 over 6. Kind of interested to see. Let's see, we're on what, number 7? Okay, so we're going to take an I out, but 44 is 2 times 22 and 2 times 11. So this, starting a new line here, is 2 plus or minus 2i radical 11 over 6. All right, well that should reduce to 1 plus or minus I radical 11 over 3. Okay, and that is our answer. You can put the I on either side of that radical 11, you just don't put it underneath of it. Okay, so that's number 7. All right, so that's 10, 17, 7. Looks like we got 8, 16, and 11. 8. Solve by completing the square gives me negative 7 plus 2x squared equals 4x. Okay, we're just going to solve this using the quadratic. So we're going to move everything around. So we've got 2x squared minus 4x minus 7 equals 0. Okay, 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 7 all over 2 times 2. We got 4 plus or minus all over 4. We got 16. Looks like that should be plus. We've got 8 times 7, so it should be 56 if I'm not mistaken. Let's start a new row. So we got 4 plus or minus square root 16 and 56. Let's see, that'd be 62, 72 over 4. Let's take 72 and break it down. That'd be 2 and 36, 2 and 18, 2 and 9, 3 and 3. So I can take out a 2, I can take out a 3, but I'm going to have to leave a 2. All right, so we end up with 4 plus or minus 6 radical 2 over 4. It would be 1 plus or minus, let's see, be 3 radical 2 over 2. Let's see if I'm right there. That would work, or 2 plus or minus 3 radical 2 all over 2. Either one. Okay. Oh. Okay. All right. I think that's 8. So we're going to hit 16. Sphere has a radius. Sphere has a radius of 9 centimeters. We want the volume and surface area. Well, the volume is 4/3 pi r cubed. Surface area is 4 pi r squared. So we have 4/3 pi 9 cubed, and we have 4 pi 9 squared. All right, so 4/3 pi, we need 9 cubed. 9 times 9 times 9, or 81 times 9. Okay, that gives me 729. And now we need 729 times 4, and then divided by 3. Times 4 is 2,916. Divided by 3 comes out to 972 pi. We want to check our units so we don't miss points on that. Centimeters. We're talking about volume, so we're cubed. Let's check our answer. On number 16, 972 pi. All right. Over here, for my surface area, I'm going to make sure that we understand that this is volume. Okay. We've got 4 pi 81. I think that's about a 4 times 81. 324 pi. So surface area equals 324 pi centimeters squared. Okay. Remember to label with your units, or these will be counted at least a half off. Okay, need to know. Label it volume, label it surface area. All right, one more. $11. Got him? 11. Let's see, is the following argument valid or invalid? All English teachers like Shakespeare. Okay? English teachers is my major premise. Shakespeare likes Shakespeare is my minor. Okay? So in their next statement, they say, Miss Backer is an English teacher. Therefore, Miss Backer likes Shakespeare. Because she's an English teacher, she's attached to the major premise, therefore assuming that she likes Shakespeare is a true statement. True or valid. If they had said Miss Baker likes Shakespeare, therefore she's an English teacher, that would have been invalid. All right, that's 11. I've got some time here, so let's go ahead and pick up another one. Let's do number 1. Number 1, the ratio of priests to acolytes. Priests to acolytes is 2 to 3. So 2a equals 3p. If their combined total was 85, meaning priest plus acolytes equals 85. Okay, the question is how many were acolytes? Okay, so if we want to do that, we're going to take this equation here and actually solve it for p. So p equals 85 minus a. And what we're going to do is we're going to take this and we're going to substitute it in right there. So we say 2a equals 3 times 85 minus a. You'll notice that that gets everything in terms of a, so I'm solving for acolytes, which is what the question asked for. So we got 3 times 85, which is 255, minus 3a. Okay, we're going to add 3a to both sides, so we get our a's together. Gives me 5a equals 255. Of course, I think by now you know you're going to divide by 5, and you should get 51 acolytes. Okay, that's what you're solving for now. If for chance you would end up solving for priests first, you'd simply subtract priests from your 85, and I'd leave you with your acolytes. Alright, just so nobody's complaining to me about not doing a question, I think this will basically make it almost all of them, if not all of them, would be number, what, 18? 18. If I can find the work for it. State the congruency postulate. So based upon all the information that they give you something like this, and they tell you that this angle is congruent to this angle is congruent to that angle, this side's congruent to this side. And based upon this, we want to prove that these two triangles are congruent. You only really need one thing, and that's to know that this line here is congruent. So AC is congruent to AC, and that's the reflexive axiom. Okay. Because of that, we know that these two triangles are congruent through the side angle side congruency postulate. That's all it needs. It just needs to know the congruency postulate, but you need to know that segment AC is congruent to segment AC through the reflexive axiom in order to know that it's the side angle side congruency postulate. Okay? All right. If I count up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 17. I don't know what question didn't get asked or that I didn't do, but that should be almost all of them. So I'm going to stop it right here and let you guys study for your test.